Okay. Now let's look at the expression like y equals x minus 3 times x plus 5. You know, when we graph linear functions, we're going to find the intercepts. Then we graph a straight line through the intercepts, and we can easily figure out what the equation of the line is. Just did that, recently. Okay, so the y-intercept of this thing is going to occur when x equals 0. And the x-intercept when y is 0. Well, let's figure out the y-intercept. X equals 0. Y is negative 15. That's real easy. Plug in x equals 0. So if we have a graph over here, we're not sure where it goes, but we do know it goes through negative 15. That's not where I want to label it. What's going to happen? Never mind, that's all right. 0 minus 15. That's the y-intercept. So it's usually very easy to find the y-intercept of a function. You just let x equal 0 because, of course, that's what you have if you're on the y-axis. The x-coordinate at any point in the y-axis is 0. Okay, well, the x-intercept is a little bit trickier. As x-intercept occurs when y is 0, and if y equals 0, then x minus 0 times x plus 5 equals 0. Now, depending what x is, this is one number times another number, right? Now, how can it be that the product of two numbers is 0? Can you write down an example, or give me an example with your one hand and the other hand of a couple simple numbers that multiply out to 0? I hate to ask you to use hand language, but we want to use this video, so we can't have you identifying yourself by sneezing, coughing, or talking. Okay? Or walking in front of the camera. So, can you give me two numbers? Here, I'm going to give you a number. There. Okay? What would you multiply this by in order to get 0? Yeah. So, if this number is 0, then you know the product is 0. And if this number is 0, you know the product is 0. Okay? So this is true. If x minus 3 is 0, it's also true if x plus 5 is 0, right? So we can solve x minus 3 equals 0 and x plus 5 equals 0. And we get x equals 3 or x equals negative 5. Now that's a lot of trouble to do something that's kind of obvious, in this case, that what would make this 0? Well, 3 here, right? And what would make this 0? Negative 5. It's not as obvious if you have like 7x minus 38 or some more complicated expression in here. Okay, well, we conclude that the intercepts are 3, 0. because again, we're looking for y equal to 0. Y is 0 if x is 3, or if x is -5. Now, this graph, not real clear how to graph it unless you understand that this is a quadratic function with a parabolic graph. But I'll draw it correctly. If you drew it even less symmetrically than I did, because mine is very symmetric, okay? This thing is supposed to be symmetric about a point halfway between here. But you don't know. Yeah, we're going to assume we don't know that. And that idea is not real useful for doing a polynomial with more factors. Okay? Okay, well, how about this? Well, the y-intercept I'll abbreviate it a little bit. X equals 0. -7 times 3 times 6, -126. X-intercept occurs, and this is a X-intercepts occur when y equals 0, so x minus 7 equals 0, or 2x plus 3 equals 0, or x plus 6 equals 0. So this tells you that x equals 7. This tells you that x is -3/2. This tells you that x is -6. No big deal, right? Easy to figure it out if you have a polynomial in factored form. Now there's quite a bit more to it, as you'll see with the open math assignment, and we'll have a quiz next time on that. Assuming that is due Wednesday, and I'm pretty sure it is. So if you do the graph, you're going to have a 0 out here at 7. You're going to have 0 here at -6. We'll go ahead and put the coordinates in. And you're going to have a 0 at -3/2. Let's see how I'm going to want to do this. Now there's another thing. If x is a negative number to the left of -6, then all three of these factors are going to be negative. Okay? Because, for example, 2x plus 3 is positive if x is bigger than -3/2 and negative if it's less than 3/2, right? X minus 7 is positive to the right of 7, 0, and negative to the left. And x plus 6, positive on this side of x plus 6, negative on this side. So if you're anywhere on this side, all three of these are negative. They also get really big. Okay, if x is like -100, then that's going to be like 100 times 200 times 100, -100, okay? And it's like -2 million. So it points way down there. Probably have to drill holes through the floor and down, well into, maybe as far as the mantle of the earth, I don't know. Okay? Nobody's ever drilled that far. So I'm not gonna do it. So I'm not gonna try to put that point on the graph. Negative 100 isn't that far over there. Just, maybe out in the hall someplace, but not that far. We don't have to go far to get to negative 100 in the x-axis, but to get to negative 1,000,000 in the y, forget it. So it means we're gonna come up from down here, and we're gonna come up very quickly. But then we've got to go through this point, and we're going to be moving down when we get through this. We're going to have to turn around and come back up through this one, because of course to the right of all these points, all three numbers are positive, right? Okay. Well, 2 minutes overtime, and if you understand that much, it's a real good start. There's more to it. Hopefully you won't find it too difficult. If you do, email me, come on in, we'll talk about it. Okay?